Your car won't start, and the first thing you might think is that the battery needs to be replaced. But what if the battery isn't completely dead? In some cases, an older 12-volt lead-acid battery may be reconditioned instead of immediately throwing it away. Today, we'll look at how the process works and, more importantly, which batteries should never be reconditioned. Your car battery does much more than simply start the engine. It provides the electrical power needed to crank the engine and help supply power to the vehicle's electrical systems. A typical conventional car uses a 12-volt battery, although the actual voltage can vary depending on its state of charge. Like almost every component in a car, a battery eventually loses performance. According to J.D. Power, a typical 12-volt car battery may last around 3 to 5 years under normal conditions. Repeated charging and discharging gradually reduces its ability to hold a charge. But don't start taking the battery apart just because the car won't start. The first step is checking its physical condition. A battery with heavy corrosion, cracks, swelling, or other physical damage may be unsafe and should not be reconditioned. Reconditioning a lead-acid battery isn't a simple cleaning job. The process can involve corrosive battery acid and electrical equipment. If you're working with this type of battery, use chemical-resistant gloves, safety goggles, and work in a well-ventilated area. The process requires several basic tools. These can include a multimeter, battery charger, toothbrush, terminal cleaning material, a screwdriver, a funnel, plastic containers, distilled water, baking soda, and Epsom salt. Having the right equipment is important before you begin. Start with the outside of the battery. Corrosion around the terminals can interfere with electrical connections. J.D. Power describes using a mixture of baking soda and distilled water to clean light or moderate corrosion. Apply the mixture and gently scrub the affected area. For heavier corrosion, a more abrasive cleaning material may be needed. After the corrosion is removed, the terminal should be rinsed and thoroughly dried. The goal is to restore a clean connection before testing the battery. Now it's time to find out whether the battery is actually a candidate for reconditioning. Connect a multimeter to the battery terminals and check the voltage. According to the J.D. Power Guide, a healthy, fully charged battery should read around 12.6 volts or higher. The voltage reading can tell you a lot. J.D. Power states that a battery reading below 12.6 volts, but above 10 volts may still be a candidate for reconditioning. But if the reading falls below 10 volts, the battery may have progressed too far and replacement is recommended. So what's actually going wrong inside an aging lead-acid battery? One major problem is called sulfation. When a battery remains undercharged, lead sulfate crystals can build up on the battery's internal plates. Over time, these crystals can reduce the battery's ability to store and deliver energy. If the battery passes the initial inspection and voltage test, the next stage described by J.D. Power involves accessing the battery cells. A typical conventional battery contains 6 cells. This is the point where the process becomes much more hazardous because the cells contain sulfuric acid. Battery electrolyte contains sulfuric acid, which is highly corrosive. This isn't something you should handle casually. The original guide recommends carefully collecting the electrolyte and neutralizing it, with disposal handled through an appropriate hazardous waste or recycling facility. The next stage involves cleaning the battery cells using a baking soda and water solution. The solution is introduced into the cells. The battery is carefully agitated, and the solution is then removed. The purpose is to neutralize remaining acid inside the battery. After the cells are cleaned, the guide describes preparing a new electrolyte mixture using distilled water and Epsom salt. The solution is mixed until clear and then introduced into the battery cells. Again, this is a chemical procedure that requires proper protective equipment and handling. The battery is then connected to a charger for a controlled, slow charging process. The J.D. Power Guide describes using a 12-volt charger at 2 amps for approximately 24 to 36 hours. The idea is to give the battery a slow charge while attempting to reverse some of the sulfation. After charging, disconnect the battery and test it again with the multimeter. According to the guide, a reconditioned battery should show approximately 12.4 to 12.6 volts. If the voltage remains too low, another charging cycle may be necessary. But voltage alone isn't the whole story. Once the battery is reinstalled, You can perform a basic load check by turning the vehicle's electrical system on and switching on the headlights. A healthy battery should keep the headlights operating without obvious dimming or flickering. And this is important. Reconditioning isn't a magic solution for every dead battery. If the battery is cracked, swollen, heavily corroded, physically damaged, or fails the voltage checks, replacement may be the safer choice. A battery that has suffered serious internal damage shouldn't be forced back into service. Reconditioning can potentially extend the useful life of an aging lead-acid battery, but it isn't suitable for every situation. The key is to inspect the battery first, test its voltage, use the right safety equipment, and handle battery acid responsibly. If the battery is too damaged, replacing it is the better option. And remember, proper maintenance and keeping a battery adequately charged can help extend its useful life in the first place.